All right, so this is the video for the thermodynamics of a calcium chloride solution. When we add calcium chloride to water, as it forms a solution, there is a delta H, the change in enthalpy, delta G, the change in free energy, and the delta S, the change in entropy for that process. And to find those three terms requires a lot of little experiments that we're going to do. So nothing's going to seem too connected in this lab, but once we have all the data, when we do the calculations, it'll make a lot more sense. But it has to be done this way. It's a fairly complex set of things going on here. Okay, so first thing is we need to obtain a 600 ml beaker, fill it halfway with tap water, and then set it on a hot plate, and then crank this up. And we're going to be boiling that water, but we want it to be a slow boil. We don't want it just going all over the place and bouncing the beaker around. So if that happens, we will bring down the temperature. And we're going to be using this throughout the lab, so if we start to lose water over time, we're going to just keep adding water into it. We're not going to let it get all the way down to here from boiling away, and then refill it. We want to just refill it as we go. Okay, so that's the first step. So next, we're going to take one of these large test tubes, and we're going to add to it 10 mils of distilled water. Normally I'd be holding it here, but this is the beaker's for stability. Just trying to keep out of the way of this. And then we'll add a thermometer to it, into the test tube in the water. And then we put this into the water bath. Now, and we're going to let that heat up, the solution, or the water inside, we're going to let that heat up to 60 degrees Celsius or above. We don't want it to be too high, but we want it to be above 60, so that when we mix it with the cool water, there will be a big temperature change. Now we're going to take a plastic test tube, and we're going to put in 10 mils of water into this one. So this is at room temperature. We're going to add in a thermometer. And this is heating up. It's at 40 degrees Celsius. So when this gets to around 60, we're going to figure out exactly what, let's say it goes to 62. I'm going to write down 62, and then take this test tube and pour the water into here. And that's going to mix with the room temperature water. And then we will see what the result is. Because what we're trying to do, if you took 1170, then you will know that we did this experiment before to find the heat capacity of the calorimeter. We used a coffee cup calorimeter for that. Here we're going to be using this plastic one. Okay, and the temperature at room temperature here is 21.5. 21.5. All right, so this is at 65 degrees. And one of the reasons not to let it go too much hotter is that I can pour it now without hurting myself, burning my fingers. Put that in. Then we're going to put in the thermometer and see where it ends up. So it's going to raise up and jiggle this around, and we end up with 38.5. Now we're going to measure the temperature change of the calcium chloride solution. Right now this is 6 mils of distilled water, and I have 4.416 grams of calcium chloride in here. In the lab it says to weigh out 4.4xx. And what that means, when you see those x's, that means you need to have 4.4 grams, and then whatever those two x's are, doesn't matter. It can be anywhere from 00 to 99, that's fine. And whatever it turns out being for mine, it was 16, that's cool. But you have to write down exactly what it is, but you have some play in those last two digits. So I have 4.416 grams of calcium chloride here, and I'm going to put it into here, and then I'm going to cap it off, and I'm going to use this bench mixer to mix it up thoroughly, and then I'm going to put the thermometer in. So it all has to happen pretty fast. This is plastic, and it'll hold in the heat for a short period of time, not for hours or minutes. It's just probably got 30 or 40 seconds before it starts leaching the heat out significantly. So we've got to do this quickly but carefully. So I'm going to pour this in. Oops. Gotta get it all in there. Cap it off so it doesn't spray around when we do the bench mixer. And what we want is to get a saturated solution, and I put in so much calcium chloride that it's going to leave some behind. We want that. That way we know that what's here is saturated. And then we're going to put this in, and you can't see the temperature rising. And again, as long as this is happening relatively quickly, most of the heat's going to stay in the solution long enough so that we can get a good temperature reading. We might be off by a degree or so, but from doing this experiment many times, it works out pretty well with the results. So we can see that it's holding steady. And I'm going to look at it here. So it was at 43 degrees Celsius, and it's already starting to drop. But we can count on that being a pretty good estimate. So 43 degrees Celsius. All right, so we have a ball bearing that we're going to use. And if you're careful, you can pick it up. Oops. But we don't want to do that right now to put it into the water bath, which is coming up next. We put it into a crucible just for that, so it's easy to move around and take out. Find that if you just put the ball bearing in there and it slips out of your grip, it's going to go and it's going to break the beaker. So it's going to put this in, and when we take it back out, there's going to be water in that crucible, and that's fine. But what we want is the ball bearing to sit in there for a few minutes and get up to 100 degrees Celsius, or whatever this has gotten to. I shut it off for a little bit, so it's at 90. So I'm gonna not have you watch it while it heats up, but once it gets to 100, we'll let it sit for about 3 minutes, and then we're going to take the ball bearing and put it into another test tube with water, and this will allow us to find the specific heat of the ball bearing. One thing I should mention, I moved this around, and hot plates are hot. And it's good to remember that. Sometimes if there's nothing boiling on it, you forget that it's on and it's sitting there. It's really hot. And I knew that, but when somebody knocked on the door, I looked up and I caught my edge of my thumb on this just for a moment. Didn't blister, but man, yes, hot plates are hot. So always be aware of that. If you got a hot plate going throughout an experiment, very often you can have your elbow touch it or your hand as you're moving around, so just be careful, unlike me. Okay, so we'll let that heat up. Okay, you can see that the water is boiling. I'm going to turn this down, and I'm going to take out the crucible tongs, and I'm going to take the ball bearing and put it into this test tube that has just distilled water in it. And I'm going to you want to roll the ball bearing in. You don't want to drop it in. If you drop it in, it does something like that, and I forgot. So this is the second try out here. Okay, so whoops. And water comes out with it, which is good because sometimes it takes a little time to get a hold of the ball bearing. And so I'm going to have this, and oops, let me put it up here, you can see it. In you go, slide that down, goes in. Gonna mix it around a little bit, and then put the thermometer in. Be careful, you got a piece of metal in there and a very thin glass tube, so you want to make sure you don't break anything. Let's make sure the water's getting mixed up thoroughly. And it's at 31 degrees Celsius. 31.5. I think all the heat that's going to come out of that ball bearing has come out. 31.6 as far as it's gone. Okay, and then we're going to put the ball bearing back into the water bath, heat it up, and then we're going to put it into the calcium chloride solution we did before. And then that will give us all the data that we need for the calculations. All right, we have the ball bearing back up to 99 degrees Celsius. And take this out carefully. Down we go. And then this is the calcium chloride solution from earlier. And I'm going to put the ball bearing into that solution, and that will give us the information we need to know about the specific heat of the calcium chloride solution. Get the thermometer in here. Okay. Again, mixing it up with a thermometer in there and a ball bearing. Got to be careful. We're at 35. See, with the calcium chloride in there, it distributes the heat faster, and the temperature goes up more. Looks like we're at 38 even. 38.5, looks like it's leveling out. Yeah, it's going down, so 38.5.